It's my opinion, but I think I'm right, like a right triangle. This is the most famous formula in math. It's the Pythagorean Theorem. I want you to look at this. Here's c squared, and here's a squared plus b squared. It's still 90 degrees, and these two things are still the same. What if you would think 89.9 would do it, but it doesn't. Look, it has to be exactly 90. Find the missing side of this triangle. This is just a warm-up. Something to remember is that the hypotenuse, the longest side, is always going to be across from the 90-degree angles. Honestly, it doesn't matter which side is A and B. Those two can be interchanged. You just got to make sure you get the C right. So let's do 9 squared plus x squared equals 15 squared. And let's square those numbers. 81 plus x squared equals 225. Subtract 81 from both sides. And that would end up being x squared equal to 144. I haven't solved for x, I solved for x squared. Now to go to the next step, you have to do the square root of both sides. And the square root and the square will cancel each other out. Those are opposite operations. And so that'll get you the x. And then the square root of 144 is 12. We don't use the negatives in geometry because sometimes we do, but not in this case. We're looking for a side length. All right, let's do it again. Find the missing side of the triangle, but we're going to leave our answers in simplest radical form. It makes it a little more complicated towards the end, but the beginning is the same. Find your hypotenuse. Label your other two sides. Start up your Pythagorean theorem. A squared plus b squared equals c squared. So we have x squared plus 4 squared equals 12 squared. Square up those numbers and subtract 16 from 144. We have x squared equals 128. Take the square root of both sides. Now we have an issue because 128 is not one of the perfect squares. So here's what you have to do. We know that the square root of x squared is x. We're going to take that 128 and we're going to break it up. And you don't have to break it up completely. You just need to break it up so you know what perfect squares are inside of that, which perfect squares are factors. So that means 128 is 4 times 16 times 2. You see those two perfect squares in there? Well, you can do this property with square roots. You got 3 numbers inside of one square root sign. You can break that up into 3 little square root problems. Now the square root of 4 is 2. The square root of 16 is 4. And the square root of 2 is an irrational number. It's not going to be a nice integer, so we're going to just leave it as the square root of 2. The last step is just to multiply the 2 and the 4. And that is how you break down and simplify square roots, and I do have a video on that people like a lot, so I'm going to put that up here in the corner for you so you can go look at that if you want to. That's our answer. All right, another way to use the Pythagorean theorem is just to answer yes and no questions about is this even a right triangle. If you have 3 triangle lengths, even if it's not written on a diagram like this, you can use the theorem to see if everything works. You have to make sure, though, that the longest length that you're given is the one that you're going to call C. That's important. The other two can be whatever. So we're going to check to see if C squared actually equals A squared plus B squared. If you're uncomfortable with me writing this backwards, I'm going to tell you that I like writing it backwards more after doing these kinds of problems. I'm going to take the 15 and I'm going to square it, and I'm going to take the 5 squared and the 12 squared and add those two together. I don't have an equal sign here because I don't know if they're equal. That's the point. If they are equal, then this is a right triangle. They're not equal. If c squared doesn't equal a squared plus b squared, you can say, no, this is not a right triangle. It doesn't matter how it's drawn. Later on in the course, we're going to figure out a way to find out how big this angle is right here. It might be like 89.9, but it's not exactly 90. Another thing they're going to ask you to do in geometry is to determine not just if it's a right triangle, but what kind of triangle is it? Is it acute? Is it obtuse? Or is it right? Back here, I want you to pay attention to how c squared and a squared plus b squared are relating to each other. So if that angle is less than 90 degrees, you're talking about an acute triangle. And look at these numbers. C squared is 156 and a squared plus b squared is 206. C squared is smaller than a squared plus b squared, and we have this cute little triangle. You know, like acute, you get it? Oh, dad jokes in geometry. All right, let's go the other way with that. Let me make that angle over 90 degrees. It's now an obtuse angle, which makes this an obtuse triangle. Look what's going on with c squared. It's 319. A squared plus b squared is 227. That's not going to change, guys. I make that angle bigger and bigger and bigger and bigger. That's an obtuse triangle, and c squared is always going to be bigger than that. All right, let's get this in your notebook if you are taking notes. Otherwise, just watch. This is a nice comparison. C squared equals a squared plus b squared. Think c squared equals, it's a right triangle. If c squared is less than a squared plus b squared, think c squared smaller. If c squared is smaller, then it's acute. And if c squared is greater than a squared plus b squared, think c squared bigger than, then you're talking about an obtuse triangle. We're going to give you the 3 measurements. You're going to figure out what triangle it is. The reason I like to write the c squared first is because that makes this all work nice. If c squared is the smaller of the comparisons, you can use the less than symbol right here and think c squared smaller, c squared equals, c squared bigger. If you flip it and put the a squared plus b squared first, you end up with things here like a squared plus b squared greater than c squared. It doesn't change the relationship of the numbers. It just makes your brain do flip-flops when you see the greater than sign and think smaller than. I like to keep these two things consistent in their concepts. Less than, smaller than. So let's go back to look at this one. We know it's not a right triangle. What kind of triangle is it? Well, 225 is greater than 169. So c squared is bigger than a squared plus b squared, which means this is an obtuse triangle. That's not the answering of the question. It was a yes or no, but now we know it's obtuse. I need you to tell me whether or not the triangle is acute, obtuse, or right. We know what the side lengths are. Let's do these one at a time. 13, we're on this triangle. 13 is the largest, so that's my C. I am going to compare 13 squared to 12 squared plus 8 squared. I don't know the relationship yet, so I didn't put a symbol here. Now we just do the math. We do the math again. Oop, now we know. 169 is smaller than 208, so c squared is smaller than a squared plus b squared. Small means acute. It's just a cute little triangle. Okay, let's go to this one. C is 10. So we're going to compare 10 squared to 5 squared plus 8 squared. We get 100, and we get 25 plus 64. Do the math again. Okay, 100 is bigger than 89, so that means we have c squared greater than, c squared bigger. Obtuse. It's an obtuse triangle. Okay, it's your turn. When the timer's up, I'm going to show you the answers. I hope you got those. Hey, if you like how I teach, it helps me a ton. If you like, comment, share, so I can find more students that I can help here on YouTube. Thank you guys for watching. Bye.